Assalamu alaikum. Shahir, can you hear me?
Yes, hello. Come, I can hear you.
Shahir, quite a bit late today.
Yes, the previous class, that's right.
Acha, we were doing dipole effect, right? We started
Yeah.
this topic, and this is the chapter we are doing is bonding. And we had started this chapter 2 classes back, and I want to show you that how we are. This is our topic number 3, bonding and structure. This chapter consists of ionic bonding, covalent bonding, shapes of molecule, metallic bonding. These are the 4 titles in it. These are the 4 titles in this topic. And when you remember that we started with ionic bonding, covalent bonding, and we were in this topic, we were last time we did shapes of molecule, and also we had started the concept of dipole moment. I hope if you remember that if there is a polarity in a molecule, remember this word, Shahid, the word molecule is very important to understand in chemistry. The word molecule means it is bonded wise, it is covalent. You will not say that sodium chloride is a molecule. You can say carbon dioxide is a molecule, but you can't say that sodium chloride is a molecule. Why? Because sodium chloride is an ionic compound. So let's make the first concept for today. The term molecule is used for covalent compounds only. Only for covalent compounds, we use this terminology molecule. Okay. Now, what is dipole? In hydrogen chloride, hydrogen is less electronegative than chlorine. So chlorine acquires a partial negative, hydrogen acquires a partial positive. This is called dipole, and every polar covalent bond that is there which has a dipole. Dipole effect is like a vector effect. And remember, it's a game of the shape. It is a straight molecule, so resultant is 0. It's a bent shape, resultant is not 0. We discussed that, for example, CO2, carbon dioxide, is a linear molecule, so the dipole is 0. But water is a bent shape, so dipole is not 0. Now, can you check, had we given the heading polar molecules?
Hold 1 second.
Can you check that? I think last thing we did this one.
Yeah, last thing we did was, we gave the heading, we didn't start it.
Okay, now polar molecule is our new heading. If we have given this heading, then it's fine. Otherwise, give this heading, polar molecules.
Yeah, given.
Okay, remember that when you want to find the polarity of a molecule, you need 2 concepts to remember. You need to do 2 concepts in your memory. One is the shapes of molecule.
Okay.
And second concept is electronegativity. You need to remember these 2 concepts, shapes of molecules and electronegativity. Now, this is a polar molecule. One side is positive and one side is negative. Polarity of a molecule depends upon 2 things, electronegativity and the shape. This is our second concept for today. Now you have to copy this.
Yeah, done. Got it.
So this is something we are connecting from the back. If a molecule contain only non-polar bonds like methane, the molecule is always non-polar. Now, this is a common sense approach. If all the bonds are non-polar, if all the bonds are non-polar, then definitely the molecule will also be non-polar, because polarity first need the polarity of the bond. If you want to check the polarity, what is the first thing to check? That the bonds are polar or not. Now look at this. CH bond is non-polar because the electronegativity difference is very small. So if a molecule contains only non-polar bonds like methane, the molecule is always non-polar. You have to copy this screen. This is our third concept for today.
Yeah, got it. Yeah, copied it down.
Good. Can you remind for me what is the meaning of dotted line in a geometrical shape?
In the page, right?
In this one, what is the purpose of dotted line in the page? What is the
The page.
purpose of this wedge?
Out of the page.
Now, this is a very helpful table to understand, because chemistry always takes time, because it's a core topic. It's something which needs time, past papers, theory revision, and we actually want to finish the majority part of our unit 1. And I will be always asking you that you keep in touch even after the time is over, that you should do questions with MCQs, theory also. Chemistry works in this way, that it's a memory connected science. You remember the concepts, you connect them, and then you can solve. Now, let's summarize it. When electronegativity is difference is zero, like chlorine, it's a non-polar molecule. When the difference of electronegativity is large, bond is polar. And when electronegativity difference is small, then molecule is non-polar, bond is non-polar. Remember, if the bond is polar, then the question comes about the molecule. If the bond is non-polar, the question finishes. Obviously, when the bonds are non-polar, there is no question of polarity of the molecule. Shape. Dipole cancel it out, either molecule becomes non-polar. Dipoles do not cancel out each other, molecule is polar. Now, this is a very important thing to remember. You have to copy this.
Yeah.
This diagram shows that you have to first justify that the bond is polar or not. Secondly, then you have to see that the dipoles are canceling each other or not.
Okay. Yeah, done.
Now look at this. This is a straight shape. This is a straight shape and this is a bent shape. If the forces are canceling each other in a linear shape, the resultant is zero. Now, let's polarity of a molecule. Bond polarity, check the difference of electronegativity. Shape of molecule, check VSEPR, or hybridization is not a concern now. And logic of vector analysis. The third is very important to understand, but I think you take physics also, so you can understand that forces which are opposite to each other will cancel each other if they are equal. Okay. Now this is a type of summary to decide the polarity. You have to copy this screen. I'm just coming. Copy this screen.
Okay.
System was already in place. If I remember, this was the system without we are going, yeah. 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 So this was kind of retrospective, and she got the services already, and got everybody in that position that nobody can say no to subcontractor. Hmm. Yeah. Yeah. So, yeah.
Well, I'm still
This
copying
is,
though. Could you just go
oh,
back?
sorry. Okay.
Yeah, okay, you can go next.
This is one of their favorite molecule, water. Water molecule is a polar molecule with a bond angle of 104.5. In my last class, I told you to memorize some important angles like water, like ammonia, like methane. I shared with you some notes also, and it would be ideal if you remember them. Now, this is water molecule. The resultant dipole is not zero because the molecule is in a bent shape. Due to the bent shape, water molecules polarities do not cancel each. And why it's a bent shape? Because it has a lone pair. Why it has a bent shape? Because the molecule has lone pair. And I hope if you remember that lone pair actually, lone pair repulsion is always more than shared pair.
Okay.
Now you have to copy this example.
Copying.
Yeah.
Yeah, done. Copied it.
Now, this is the second example, CCl4. We call it tetrachloromethane. Now, this molecule has a geometrical shape which is cancelling all the bonds. All the bonds are polar. All the bonds are polar, but molecule is non-polar. Why? The first question is from my side. Why all the bonds are polar? All the bonds are polar. So can you tell me why all the bonds are polar? Because there is a difference of electronegativity. Carbon is electropositive.
Because that is not correct.
Yeah, I think it's because the net dipole is zero, right? That's why.
The dipole, actually the dipole concept comes when you want to decide the polarity of a molecule. Make it clear. There is a concept of bond polarity and there is a concept of molecules polarity. A bond is polar when the difference of electronegativity is large. A molecule is polar when the dipoles do not cancel each other. I repeat, carefully listen, that there are two different concepts, bond polarity and molecule polarity. Bond polarity comes from the difference of electronegativity and the molecule polarity comes from the shape. It is the shape. If the bond polarities cancel out each other, then overall the molecule will be non-polar.
Yep.
Okay, now give the side heading CCl4. Now you have to copy this.
By the way, what's EN? EN? Is it
N,
electronegativity?
yes, EN
Right.
stands for electronegativity.
Okay. So like a change in negativity,
Difference.
is it?
Difference
i-
of
i-
electronegativity,
Yeah.
is called delta En. So if one element is electropositive, one element is electronegative, its bond will be polar. So if you make a bond between, look at the example, if you make a bond between carbon and carbon, it will always be
But these are not consistent.
Non-polar.
non-polar.
Take approval one
Bond
month, they do
between
not see what
carbon
is paid
hydrogen,
during that time.
the difference
And
is small,
approvals are being repeated as
but
well.
bond
So that
between
there also we need
carbon
to be a
and
little bit
chlorine,
on
now this
So,
bond will be,
So we will have that because I tried to find it through Oracle.
if you want to
And
copy this, you can
Some
also.
support over there.
yeah, I was gonna ask for from the previous notes. I didn't understand what is a hybridization. Am I supposed to copy it
Hybridization,
or?
hybridization is not in our course. I think I cancelled it when you were copying now. So you're
Yeah,
not
you did.
supposed to copy this hybridization. It's not required now. So
Okay.
can you please repeat the concept for me? There is a concept of bond polarity and there is a concept of molecule polarity. What is the difference
Which is
between
not
them?
visible to PM or
The difference between?
one shot.
The
That is
difference between the
subcontractor.
concept of there is
Right?
some background noise
So
actually. I
the
think that's why you
information,
can't hear
you
me
have
properly.
information.
It is a concept of bond polarity and molecule polarity. It's a concept of there are two concepts. One is the polarity of a bond and second is the polarity of a molecule. So you always have
Bond polarity would be to do with the electronegativity, right? The net
Yes.
electronegativity, and the molecule would be to do with the net dipole.
Yes. So we first decide the bond polarity. We first decide the bond polarity, and then we decide the molecule's polarity. Now look at this third example. This molecule is called carbon tetrachloride. It is also called chloroform. Now you copy this example.
Once again, could you go back to the last notes? I'll take a screenshot instead. Once.
Mm,
Right.
you,
Okay.
I think you had copied it.
No, the second part, it's gone. Okay.
You can copy it, no problem.
Okay. Yeah, I got it.
Now see, now you copy this example.
What exactly does it mean, like when it says the molecule is polar or isn't polar? Like what
Overall
exactly?
polarity. Now you can see overall polarity is like a vector concept. The molecule polarity, look this polarity, look this polarity is being cancelled by this one. They are facing each other, so they cancel each other. But this upward polarity is not cancelled by the downward. This is a polarity which is left over because the lower CH bond is not polar. And that is why polarity do not cancel each other. I want to get you back again in O-level physics. You have done O-level physics, right?
Yes.
So can you tell me this concept? It will help you a lot. Can you tell me what is the resultant force when I put a question mark?
Where? Oh, okay. Zero. Zero
5
is the
Newton on the
resultant
right,
force.
5 Newton on the left. What is the resultant force?
Zero. Yeah.
0. Why it's 0?
Because both ways it's 5 newtons, so
They
it's
cancel
not
out each
moving
other,
anywhere.
right?
Yeah.
Achha, then 5 Newton up, but there is nothing in the bottom. Then what about this vertical side? Is it 0 also there? In the
No.
vertical dimension,
No, it's
resultant
not.
force
It's
won't be 0. Why resultant force is not 0 in the vertical dimension? Let me make it red for you. The resultant force is not 0. Why?
because there is no downward force acting on it.
There is no downward force to balance. Now look the question mark. There is no downward polarity in the molecule to balance it. Now there is some polarity remaining. So that is why the molecule is polar. Have you copied it?
Yeah. So like it's the bond is non-polar when there's only a positive charge, basically. Is that what it is?
Again, I want to repeat. Bond polarity is a concept coming from difference of electronegativity. Okay. Once you decide the bond is polar, then you decide the molecule is polar or not. CH bond is non-polar because both carbon and hydrogen are electropositive. Carbon and chlorine is polar because carbon is electropositive and chlorine is electronegative. First, you decide the polarity of the bonds, and then you decide the polarity of the molecule.
Okay.
Now, example number 4, HCl. And this molecule is polar because there is no competition. It's a straight molecule. It is a straight molecule and there is no competition. There is only one polarity line. And why this bond is polar? Why this bond is polar? Because hydrogen is an electropositive and chlorine is an electronegative
Negative.
element. So now you have to copy this example. Have you copied it?
Just the last 1 second. Okay, yeah, copied.
Now HCl is a polar molecule, and now I'm putting the fifth example. You can identify it is carbon dioxide. Both bonds are polar, but the molecule is non-polar. Why molecule is non-polar?
Because the net dipole is
Yes.
Yeah.
The net polarities are cancelling each other. Now you're getting this concept. You have to copy this screen.
Okay.
Last time when it went first, so yeah, that was it. B23. So, I'm just putting the code in the center of the language. Yeah, let me check. I mean, I just remember.
Yeah, just copying it.
Have you copied it?
Just 1 second. Yeah, copied.
So now I'm putting the sixth example, that is methane.
That's what I wanted, because I thought
Methane
that
is
Yeah.
a molecule, NH3 is the formula. Now the shape of methane is there, and it is a tetrahedral. It's a base wise. It is there are 3 hydrogens, and now you have to look at this diagram. Methane, all bonds are polar. All bonds are polar, and the molecule is also polar. You have to copy example number 6.
Okay.
This is very old. Yeah, this last year. This one,
So basically, if all bonds are polar, they, well, if we talk in terms of resultant force, they basically apply a force. Is that what it is?
And it's a rule, remember, that bond polarity is not a guarantee that molecule would be polar. It is the shape of the molecule which decides the molecular polarity.
Okay.
Have you copied it?
Yeah.
Now there are many other examples.
Yeah.
And we have mentioned them. And
An atom attempts to attract electrons toward itself when bonding with another atom. The level of attraction of each atom is called its electronegativity. When sodium and chlorine react, the chlorine atom removes sodium's valence electron and becomes a chloride ion. The less electronegative sodium atom cannot compete for electrons and becomes a sodium ion. The attraction between the ions is an ionic bond. When bonding atoms have nearly equal electronegativities, neither can attract electrons away from the other. In a carbon-sulfur bond, the electron pair is shared almost equally between the two atoms, resulting in a covalent bond. When hydrogen and oxygen react, the more electronegative oxygen atom cannot completely remove an electron from hydrogen. The shared electrons are attracted more to the oxygen than to the hydrogen atom. This unequal sharing is called a polar covalent bond. Polar bonds have a slightly negative and a slightly positive end.
if you see the last screen, this one, which was there,
An atom attempts to attract electrons.
if you see this screen, it gives you a very good idea. Look, NaCl is ionic. Carbon-sulfur bond is non-polar, and hydrogen-oxygen bond is polar.
Okay.
So not all molecules containing polar bonds are polar. If bond dipoles cancel each other, the molecule is not polar. If there is a net dipole, the molecule will be polar. It's a very, very comprehensive way to summarize what we were discussing today in our class. So now you have to copy this summary. This is again a topic which needs shapes of the molecule. Sorry. Let me know if you have copied it.
Yep, copy.
Now we make this concept. Now there is a core, in your course, there are some lab work, which they call as core practical. This is called evidence for polarity. It's a lab work. And now you have to give this heading. You have to give this heading, evidence for polarity. It's a core practical. Many schools perform these experiments in class, even though they are allowed to be done without the, they can be done without the course also, without the lab also.
Yeah, I think so.
Now, experiment number 1, which I'm referring here, place a liquid in a burette, allow it to run out, place a charged rod alongside the stream of the liquid. Look at this thing. Polar molecules are attracted by the electrostatic attraction, and non-polar molecules will be unaffected. Look at this flow. Now, if a molecule is polar and you draw it from the burette, look at this diagram, it will bend. And if the molecule is non-polar, it will go straight. So this is the apparatus. You can see this is the apparatus. You can check that the molecule, the liquid is polar or not. This is experiment number 1. I will share the detail because it's a type of memory. So give a side heading, experiment number 1. Give a side heading, experiment number 1. A polar liquid will bend. A polar liquid, right under it, a polar liquid will bend towards the charged rod. A polar liquid will bend towards the charged rod while a non-polar liquid,
Will stay straight, is it?
yes, a non-polar liquid will fall undeflected.
Oh, okay.
Now give us side heading, experiment number 2. This is called dipole moment. And you can put a molecule in a strong, you can put a liquid in a strong electric field. In physics, electric field means one positive plate and one negative plate. Now, this will actually rearrange the molecules in an order.
A polar substance, as indicated by the positive and negative signs on the molecules, is placed between metal plates. When the plates are connected to an electric voltage, the polar molecules align positive to negative. A polar substance, as indicated by the positive and negative signs on the molecules, is placed between metal plates. When the plates are connected to an electric voltage, the polar molecules align positive to negative. A polar substance, as indicated by the positive and negative signs on the
Now you can see hydrogen fluoride. Can you guess for me, hydrogen fluoride, is it polar or non-polar?
No,
Hydrogen fluoride should be the bond should be non-polar, but
No,
it should
hydrogen
be
fluoride, fluorine. Remember in the last
polar.
class we discussed fluorine is the most electronegative element known, and hydrogen is an electropositive element.
You can create some work for that. So,
So
Yeah, so the bond would be
hydrogen
non-polar,
fluoride
right?
is a polar molecule. What about
The-
water we discussed today?
molecule. This is a non-polar molecule.
Water. We discussed today in detail that water is a polar molecule. Ammonia. Ammonia is a polar molecule. CCl4, today we discuss non-polar.
Yeah,
And what about CO2?
CO2 is polar.
Good.
Wait,
So
no, is it? Wait,
CO2
if
is
it,
non-polar. Even the bonds are
non-polar.
polar. No
Yeah,
doubt bonds are polar.
yeah. I
Bonds
was, I
are
was, I was
polar.
talking about bonds, not molecules. Sorry.
Yes. Bonds are polar, but the molecule is not polar. So give a heading, list of examples, so you can learn them. It's very important to learn them.
Okay.
And
But as of now, current position, there will be no change in the So, but within change, it is a little bit.
so just repeat for me. Hydrogen fluoride. Remember, fluorine is the most electronegative molecule. It's a polar molecule. Water. Very strongly remember that water is a polar molecule.
Yeah.
Ammonia, just keep on writing with me. Ammonia is a polar molecule. CCl4 is
Non-polar. Same thing with CO2.
CCl4 is non-polar.
Yeah.
Yeah, maybe he's not told you, or because the date is. No, no, he is not.
You have to copy this list to memorize it.
He asked me that how's your dog going, asked for feedback from me. So I told him he's taking care of him, that's the best. But I told him that Ritu is very much involved, so I don't have any problem. So, I mean, I told him that he takes care of the.
So this would be the summary basically of the molecule.
No. This is not a summary. This is a list of some very important molecules to memorize. Look, I always tell my students one thing, that chemistry is a memory subject. A lot of students succeed in chemistry because of strong memory. No doubt, understanding is there. If a
Could you
new
just go
molecule
back?
come, if they give a new molecule, you can't actually
Yeah.
memorize, but some molecules come in every second paper.
Okay.
So have you copied it?
Just on the last two. What's the speech marks for? The small, is it? What's the speech marks for? Like after H2O, it's like polar speech marks. What's
That's
that
the
for?
meaning of it's the same above is copied now. Polar molecule, that the double tick means same is copied as above. It's a copy parallel thing. No? Polar molecule,
okay.
water is a polar molecule, ammonia is a polar molecule.
Okay.
Have you copied it?
Yes, copied.
Molecules that have separated positive and negative centers are called polar molecules. This separation of charges is confirmed in an electric field. When the electric field is turned on, polar molecules orient their negative charge centers toward the positive plate and their positive ends toward the negative plate. Let's compare a number of molecules to show how molecular geometry can be used to predict the polarity of the molecule. Click on one of the buttons to compare those molecules. Consider the Lewis structures of sulfur dioxide, SO2, and boron trifluoride, BF3. In both structures, there are 3 VSEPR pairs of electrons around the central atom, meaning that the electron pair arrangement about the central atoms is trigonal planar. The molecular geometry of BF3 is trigonal planar, but because of the lone pair, the molecular geometry of SO2 is V-shaped.
SO2 is V-shaped bent. So it means everything actually goes on the
In BF3, there is a shift in electron density from boron to fluorine because the fluorine atom is more electronegative than the boron atom. This shift in electron density is symbolized by placing a crossed arrow next to the bond to indicate the direction of the shift. To determine if the molecule is polar, that is there a net dipole moment, we must sum together the individual bond moments. If we add together 2 of the bond moments in BF3, the resultant moment is equal and opposite to the upper bond moment. These 2 moments cancel, and the molecule is nonpolar. The dipole moment is 0. In SO2, there is a shift in electron density from sulfur to oxygen because the oxygen atom is more electronegative than the sulfur atom. Also, there is an increase in electron density in the vicinity of the lone pair. Summing together the 2 sulfur-oxygen bond moments, the resultant moment is smaller than the moment due to the lone pair. The 2 moments do not cancel, and the molecule has a net dipole moment. SO2 is polar with a dipole moment of 1.63 debye units.
Now, give a heading, properties of covalent compounds. Properties of covalent compounds. This is our next heading. Properties is something, properties are something which is, there is some background noise actually.
Yeah.
No problem. You can close the mic, and when you have to ask a question, you can. Otherwise, there's no problem. You can. Now, properties of covalent compounds. Covalent compounds are classified in 2 forms. One which are called simple molecules, and one which are called macromolecule. These are the 2 main types. Simple molecules are polar molecules and non-polar molecules. Now, after giving the heading, properties of covalent molecules, you have to copy this screen. You have to copy this.
Macro would be larger, right? Basically.
Sorry, what did you say?
What would be macromolecules?
Macromolecules are those which have a giant structure like diamond, like graphite. Do you remember diamond and graphite in
Yeah,
O-level chemistry?
yeah.
So now give us side heading simple molecules.
Okay. Done.
There are two types of simple molecules, polar and non-polar. You have to copy this.
Anarchy has the speed, but she doesn't, you cannot see her own mistake. You cannot see that. So, and then when she is
You have to copy these examples also. Have you copied it, Shahid?
Yeah, copy.
So these are called polar molecules and non-polar molecules. So atoms are joined together within the molecule by covalent bonds. Normally, they do not conduct electricity as they have no mobile ions. They tend to be more soluble in organic than in inorganic. Solubility in chemistry can be due to dissociation. Achha, first look at this property. These are some basic, these are some very basic properties like bonding. Atoms are joined together. Electrical conductivity means electricity does not pass through. Electricity does not pass through them because they do not have mobile charge carriers. Solubility is a concept which comes to us every day, that when you put some sugar in water, when you put some salt in water, when you put some liquid in another liquid, this is actually where solubility comes. So these are some very basic properties. Now we stop here, and I actually cannot extend more. Actually, we started late, but I tried to make it. And on the weekend, I can put a class. I will share you a possible slot, and you can see if you're available. We can discuss some questions, inshallah. And it's all for today. Thank you. Allah Hafiz.
Okay, Allah Hafiz.
you cannot